Hello everyone. So we are going to talk about composition over inheritance in this video. We all know that inheritance is one of the primary principle of object-oriented programming, right? We usually use inheritance to form a hierarchy of objects, and also we use inheritance to reuse the code. We want to avoid duplication of the code, and we use inheritance to do that. But there is another principle in object-oriented programming to prefer composition over inheritance. So in this video, we are going to talk about what is composition and why exactly we have to prefer composition over inheritance. Let's get started. To start with, let's see how we can implement inheritance and composition from the code perspective. So let's assume we have a class called A, and this particular class contains the functionality called foo. It has a function called foo. Now we create another class called B, and that class contains another function called bar. Now consider this class B now also needs the functionality of the function foo, which is already implemented in the class A. Consider this is the scenario. Now you can go ahead and rewrite the logic of function foo in the class B, but that would be like duplicating the code, right? And we want to avoid that. So instead of duplicating the code, we can actually extend the class B from class A. So by doing that, you automatically get the foo function, which is already implemented in the class A in the class B. So whenever a client which try to create an object for the class B, they can actually invoke both foo function and the bar function. So this is how we actually achieve the code reusability using the inheritance. Now let's take the same example and try to do composition for this scenario. Again, assume there is a class called A which has the function foo, and there is another class called B which has the function bar. Now this class B wants to implement another functionality called foo, but that function is already implemented in A. It's the same scenario. We are going to try this with composition now. Now, how do we reuse the code? How do we reuse the functionality which is already defined in the class A? Now, without extending the class B from class A, what we are going to do is we are going to just create another variable in the class B of type class A. And you define another function called foo inside the class B, and then you call the foo function of class A inside the class B, inside that particular function. So by doing that, now the class B exposes two functions, foo and bar, and especially in the foo function, you are not actually duplicating the code, but instead you are just invoking the function which is already defined in the class A. So again, we achieved the code reusability, but we didn't extend the class B from the class A. So this is called composition. Now let's try to take a simple example and see in what are all the scenarios we have to go for composition and what scenarios we need to go for inheritance. To understand this easily and in a better way, we are going to do some kind of an object modeling in animals and birds. So let's consider we have an object called duck. So we have an object called duck, and we are going to define some functionalities for this object. Let's say this particular object can swim. So there is a function that is needed in this class called swim, and we also need a function called fly because duck can fly as well. And imagine there is another function needed which is eat. Obviously duck can eat as well, right? So now imagine you have an application where you need to implement this object, and also you have to implement these functionalities for that object. Now consider there is another object. Say we have another object called eagle, and let's define the functionalities for eagle. Let's say eagle cannot swim, obviously, but it can fly, and eagle can eat. Now we have two objects which have certain number of functionalities. Now the thing that we need to notice here is there are some functionalities which are common across duck and eagle. So the functions fly and eat are common across duck and eagle, but here we don't have to go ahead and duplicate these functionalities in both the classes. So we want to achieve the code reusability. So what we actually do is people prefer inheritance in this particular scenario. So we actually can create a base class. Let's say I create a base class called flyable, and I'm going to define all the functionalities that are common across these two functions. these two objects. And those common functionalities are actually fly and eat. So I can actually remove these functions from these objects. And I'm going to extend the object duck and eagle from the flyable. So by doing this, you are actually implementing the inheritance. You actually inherit the functionalities fly and eat from the flyable object in both of these objects. So now we don't have to duplicate these functionalities. We achieve the code reusability. Now, what is the problem here? Now, we actually saying that prefer composition over inheritance. So what is wrong with inheritance, right? That's what we need to know. Now, let's assume in your project, now there is another requirement where you have to add one more object into the application. Let's say you need to add an object called plane. So let's say you need to add functionalities of an aeroplane in your project. So you add an object called the plane, and the plane comes with the functionality of fly. So you need to implement this functionality of fly in the plane class. Now you can go ahead and redefine this functionality in plane, but again, you still want to reuse the code, right? You don't want to duplicate the code. Now, what you actually prefer here is the fly function is already defined in the flyable object. So why don't we just go ahead and inherit the plane object from the flyable? By doing that, we can actually achieve the code reusability, right? So what we do is we remove the fly function from the plane object, and then you inherit it from the flyable. So by doing this, now the plane object gets the fly function. We achieved the code reusability, which is good. But there is an issue in this implementation. Since we are doing inheritance, since we are extending the plane object from the flyable object, we are not only getting the fly function, but we are also getting the eat function in the plane object. And plane object doesn't need the eat function, right? Obviously, planes are not going to eat. So this is an unnecessary information which is present in the plane object just because we implemented inheritance. And this is one of the primary problem in inheritance. This is what Joe Armstrong clearly mentioned, that this is the problem with object-oriented programming. So he mentioned, whenever you request for a banana, but instead you get a banana and you get a gorilla holding the banana and the entire jungle along with it. So you sometimes get unnecessary information into your object just because you are doing the inheritance part. And actually, this is breaking the principle of encapsulation, right? Because whoever the clients who are actually using this object plane, they only need to know the functionalities of the fly function, but they don't have to know anything about the eat function. But still, since you are doing the inheritance, the clients who use the plane objects is going to know about the eat function as well, which is actually breaking the principle of encapsulation. Now, this is where we go for composition. Now, let's see how to avoid this breaking of the principle of encapsulation with inheritance. And we are going to use composition to solve this problem. Now, in case of composition, so we are not going to extend the class from the flyable. Instead, let's say you create the class plane, but instead of extending the plane object from the flyable object, what you are going to do is you just define a variable of type flyable in the plane class. And then you're actually going to define the fly function in the plane object. And this fly function, you are actually going to call the fly function of the flyable object itself. So if you look at this class, right, so you are not actually inheriting the plane object from flyable, but instead you are still achieving the code reusability. So you declare the variable of type flyable, and then you expose the fly function, and then inside the function, you are actually reusing the function which is already implemented in the flyable object. So we achieved code reusability. Also, we didn't break the principle of encapsulation, because the clients who actually use this object plane, they only have idea about the fly function and they don't have any idea about the eat function. Even though you are using a flyable object which actually contains the eat function, which is not exposed outside. You have the full control on which function you want to expose outside, which is not the case in the inheritance. Now, this is one of the primary reasons why people prefer composition over inheritance. Now, there is another reason why people prefer composition, which is, now, in case of a composition, the behavior can be modified during runtime. The reason is this variable flyable phi, right? So F, right? So this variable can be injected into the objects through constructor, which is what we actually refer to as dependency injection. Since we were able to inject the dependencies through the constructor in the object, the behavior can be modified in the runtime. But in case of inheritance, the hierarchy of the objects is defined during the compile time itself. So basically, you are baking the relationship and the functionality into the binaries during the compile time itself. So it cannot be modified during runtime. So these are the two reasons that you have to keep in mind when you choose composition over inheritance. And there is another suggestion that people give how to identify whether to choose composition or inheritance in certain situations. And that suggestion is, so you need to identify the relationship between the objects. Say, for example, if the relationship between the objects is a relationship, if it has a relationship, then you go for inheritance. But if it has a relationship, then you go for composition. So this is one of the suggestions given by people to choose whether you want to go with composition or inheritance. Say, for example, a cat is an animal, a duck is a bird. So you actually go for inheritance in these cases, like you inherit the object cat from the class animal. But in this case, for example, an office has chairs, a computer has memory. So the relationship between the object has a relationship. So in this case, you actually go for composition. But yeah, this is one of the suggestions. It's a very good suggestion to choose between composition and inheritance, but it comes with a little bit trick. Because consider our example. Consider our example in this case. You can actually say an eagle is a flyable object. A plane is a flyable object. So obviously, yeah, it has a relationship. So we can go for inheritance, right? But you can also say eagle has a flyable characteristic, plane has a flyable characteristic. And actually, it sounds a lot more better when you use has a relationship in this particular scenario, right? So you can also go for composition. Now, this is where the confusion comes in, whether to choose composition or inheritance. So in this case, I would strongly recommend to go with composition over inheritance, because just keep in mind, whenever you are implementing the inheritance, just hold on for a minute and think whether that particular scenario can be solved using composition. If it is possible to solve that using composition, then go for composition. Don't go for inheritance. But if it is not possible to solve that using composition, then stick to inheritance. So this is what I would recommend. So this is why we call this as prefer composition over inheritance. So in this video, we talked a lot about what is composition and why we have to prefer composition over inheritance. So I'm sure this video is really helping you. Thanks a lot for watching this video. Thank you.
Audio Jungle.